Okay, so for this question, we have to create a graph to explain why this situation is linear, meaning that it's going to form a straight line. So what is the situation here? Can I get someone to read the situation for A? Okay, so the cost for a taxi ride is $4, so flat rate of $4. This is the flat rate. So even if you don't go anywhere, you still have to pay $4, right? You guys ever take a taxi? They start your meter at a certain amount even before you even start driving. Plus, it's 75 cents per kilometer. Every kilometer you drive, you get charged 75 cents. So what is the relationship here? What am I going to put on my graph? We're looking at a relationship between cost and kilometers. Does the cost depend on the kilometers you travel, or do the kilometers depend on the cost? The cost depends on how many kilometers you travel. So cost is dependent, which means it's going to go on the y-axis. Okay? Number of kilometers is independent. So that would be on the left side of the table, and cost would be on the right side. I want you to copy the table down as well. This will help you. So if we travel, always start at 0. If you don't travel anywhere, how much are you getting charged? What's the flat rate? $4. Okay? If you travel, let's count by 2s, okay? Because you probably wouldn't take a taxi to travel 1 kilometer. You can walk it. Let's just count by 2s. 2, 4, 6, 8. Let's go up to 10 kilometers. From here, table, because it's 75 cents per 1 kilometer. But I made an increase of 2 kilometers in the table. Okay, so be careful here. If you travel 2 kilometers, you have to pay the $4 flat rate plus 75 cents plus 75 cents. It's 75 cents for every kilometer. I want you to tell me what the total is for 2 kilometers.
Do they go by?
Okay, so 2 kilometers would be $5.50 because it's 75 cents per kilometer. What's 75 cents plus 75 cents? $1.50, plus you have to add the $4. Okay, so every 2 kilometers, we're going to go up by $1.50.
Oh,
So what's the next value for 4 kilometers? $7, then $8.50. No?
$10.
Thank you. Then $11.50. Okay, does everyone understand what we're doing here?
Yeah.
It's 75 cents for 1 kilometer. So 2 kilometers would be 75 cents plus 75 cents, which is $1.50. So for every 2 kilometers, it's going up by $1.50, but it starts at 0 and 4. So graph it. 0, and then my scale for X could be counting by 2s. 2, 4, 6, 8, 10. And the cost, what's a good scale? We need to get up to $11.50. 2s? Okay. 2, 4, 6, 8, 10, 12. That's a good scale. 10, 12. And we're starting at 0, 4. Okay, I want everyone to graph it right now, and I'll come around and look. 4 is 7. 6 is 8.50. 8 is 10. And 11.50. I'm going to come around and check that your graph forms a straight line. So for B, again, we're looking at a relationship between how much he earns and how many hours he works. Do his earnings depend on how many hours he's working? Yeah. Yes, so earnings is dependent, which means it's on the y-axis. Hours is on the x-axis. Okay, you can make a table, hours and earnings, how much he earns. If he works 0 hours, how much does he make? No. $0. If he works 1 hour, how much does he make? If he works 2 hours, how much does he make? 19. If he works 3 hours, how much does he make? 28.50. I want you to complete this up to 5 hours and graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How much does he earn for 4 hours? $38. And how much does he earn for 5 hours? $47.50.
Miss, you know they made a screen that can fix itself.
What's a good scale for earnings?
What 2, 3, 4?
We need to get up to $50. 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, 5 is a good scale. I'm not going to write it all. And he works 0 hours. He makes $0. 1 hour.
Y'all broke, boy.
Okay, and so on. I want you guys to. Okay, your points should form a straight line. Is this linear?
Yes.
The hours increase by 1, and the earnings increase by $9.50. It's a straight line. We automatically know it's linear.